Alright, you cool cats, this is section 2.5, quadratic equations. This is such an incredible section that we're going to split it up into 2 different days. Let me show you why. With the first problem, solve, you can take the square root of both sides of the equation. So, in order to solve, we're just going to take the square root. Canceling out that exponent, we get the absolute value of x is equal to square root of 7. And if the absolute value of x is equal to square root of 7, then that means x could be either positive or negative. And that's your answer. Next page, we have to undo the division first, dividing both sides by 5. Undo the division before we undo the exponent. So you get x squared is equal to 0, and the only number you can put in for x would be 0. You could say that this was the absolute value of x equals 0, but still, it's just x equals 0. Come on, Bergman. It's just 0. There's only one number that's going to work. Here, you could divide both sides by 3. Dividing both sides by 3. Again, we're working in reverse PEMDAS order. So that means you undo the multiplication before you undo the exponent. So we get x squared is equal to pi over 3, whatever that is, and then you take the square root of both sides. You could mess with the absolute value if you want, but in the end the answer is going to be plus or minus the square root of pi over 3. I could have shown my absolute value work if I wanted to, but you get the idea. Undo the multiplication before I undo the exponents. You get x squared is equal to n over m, so therefore x is equal to plus or minus the square root of n over m. Number 6. You get x minus 5 is equal to plus or minus the square root of 3. Adding 5 to both sides, you get x is equal to 5 plus you get x minus 5 is equal to plus or minus the square root of 3. Adding 5 to both sides, you get x is equal to 5 plus or minus the square root of 3. Again, you could write it out as 5 plus x could equal 5 plus the square root of 3, or x could equal 5 minus the square root of 3. Here, this is one step further back. I mean, if you really thought about it, what you could do is you could, as a first step, rewrite this as something that looks like this. Remember that x squared and 25 are perfect squares, so and then 10x would be your middle 2ab term. So you can factor this. This becomes x plus 5 squared once it's factored equals 4. Taking the square root of both sides, you get x plus 5 square root of both sides. Square root of both sides, you get 2. So therefore x plus 5 could equal plus or minus 2. Subtracting 5, you get negative 5 plus or minus 2. That means x could equal negative 3 or x could equal negative 7. Most people write it like this because... So basically what we worked up to is the ability to solve a perfect square trinomial is equal to any number. We're going to be working with perfect square trinomials so much that the next thing we've got to do is try and figure out how to create them even when they're not there. What that means is we're going to learn or remember how to do completing the square. It's something you may or may not have done in Algebra 1. So the instructions for the next part say find the term that completes the square. That is, divide the b term by 2 and then square it. And then fill in the second expression. So we're not always going to have a perfect square trinomial, so let's figure out how we can create it. 4 divided by 2 gives you 4 divided by 2 is 2, and then so then this is going to be x plus 2, and when you square 2 you get 4. X squared plus 4x plus 4 is something you could factor into x plus 2 squared. Again, negative 6 is the b term, so you divide it by 2 and you get negative 3. So that means this is going to be x minus 3 squared. And then negative 3 squared will give you positive 9. And then we can see x squared minus 6x plus 9 is equal to x minus 3 squared. Here, 5 divided by 2, don't fear the fraction, it's just going to be 5 over 2. So this was going to be x plus 5 over 2. And then squared is going to be 25 over 4. X squared plus 5x plus 25 over 4 can be factored into x plus 5 over 2 squared. How do we know? We created it to be that way. I want you to do number 12. So just pause the video, and when you've got 12 finished, then you can resume with 13, as I'm going to do right here. Don't fear the fraction. We got 3/4 divided by 2, or multiplied by 1/2, really, would be 3/8. So this is going to be x plus 3/8. And when you square 3/8, you get 9 over 64. X squared minus 1. Negative 1 divided by 2 is negative 1/2, or minus 1/2. And then negative 1/2 squared will give you positive 1/4. So there it is. Your audio check is that, did you know that there are 24 hours in the day? Astounding, people, I know. I wasn't quite sure of it myself, but I looked it up on Wikipedia, and Siri tells me that there are 24 hours in the day. So now we're going to solve by completing the square. And what that means is we practiced solving first, just now on the top part of the page, previous page, and then we figured out how to complete the square. So we're going to combine those two together, and we're going to solve by completing the square. So this trinomial that we have right here is not a perfect square. You might think it, I mean, even I thought it at first glance, but remember, if it's x squared minus 4x plus 4, then you can factor it into a perfect square trinomial. But right now, you can't. So what I'm going to do is I'm just going to move the c term over. by adding 4 to both sides. And what I mean by C term is the first one is the A term, then the next one is the B term and the C term. The quadratic term is the A term, the linear term is the B term, and the constant term is the C term. So then we have x squared plus 4x, I'm going to leave some space, is equal to 4. Now what should I fill that space with? Well, when you take the B term, the value of B, which is 4 divided by 2, you get 2. And then when you square 2, 2 squared is going to equal 4. So I need a positive 4 on both sides, right here. If I write that plus 4 there, then this trinomial on the left-hand side of the equation will become a perfect square. But I can't just add 4 because I want it there. So I have to add 4 to both sides, and then it'll be balanced. It'll be the same, it'll be an equivalent equation. So therefore, I'm going to factor the left-hand side. We're going to get x plus 2 squared. Remember, if I FOIL this back out, you get the original x squared plus 4x plus 4. But now this is equal to 8. 4 plus 4 is 8. Taking the square root of both sides, we get the absolute value of x plus 2 is equal to the square root of 8. And then, undoing the absolute values, we get x plus 2 is equal to plus or minus the square root of 8. A lot of people skip this step, but I like to write it out because I think it helps me remember plus or minus square root of 8. And then x, after subtracting 2, you get negative 2 plus or minus the square root of 8. You can literally solve, at this point, any quadratic equation that you get just by completing the square. Let's try that again. Number 16. So I'm going to move the C term over, minus 8. That was the first step. We get x squared minus 6x, leave it a little space, equals negative 8. Negative 6 divided by 2 is negative 3, and then negative 3 squared is positive 9. So I'm going to add a positive 9 here, and therefore also add a positive 9 over here. We get something that we can factor. That is x minus 3 squared, and then negative 8 plus 9 is 1. Taking the square root of both sides, undoing the absolute value, you get x minus 3 is equal to plus or minus 1, and therefore x has got to equal 3 plus or minus 1, because you added 3 to both sides. Just writing all out, you get 3 plus 1 is 4, or x could equal 2. Number 17. The steps are going to be the same. And don't fear the fraction. We got minus 6, x squared minus 5x, leave a little space, is equal to negative 6. Doing the side work, the b value is negative 5. Negative 5 divided by 2 is going to be negative 5 over 2. And so I'm going to even write it down here, x minus 5 over 2 squared. As a next step. Negative 5 over 2 squared becomes 25 over 4. So that's what I need to add in a little space. 25 over 4. I need to add it to both sides to get negative 6 plus 25 over 4. It factors, and when you combine negative 6 plus 25 over 4, well, I just need to make sure that I change negative 6 into negative 24 over 4. Negative 24 over 4 plus 25 over 4 gives you 1 over 4. Taking the square root of both sides, we get x minus 5 over 2 is equal to plus or minus the square root of 1 over 4. You can actually take the square root of 1 over 4. What number times itself is 1/4? That's 1/2. So x minus 5 over 2 is equal to plus or minus 1/2. Adding 5/2 to both sides. You get x is equal to 5/2 plus or minus 1/2. Splitting it up, you get x could equal 5/2 plus 1/2, or x could equal 5/2 minus 1/2. That means that x could equal 6/2, which is the same thing as 3, or x could equal 4/2, which is the same thing as 2. That's number 17. Now check this out. That's how you complete the square. And the steps are the same each time. Move the c term over, find the perfect square, complete the square, and then solve what you've completed. The instructions here say if a is not equal to 1, and you can see here a has so far equaled to 1 every time, the x squared term is always x squared. It's not 3x squared or 5x squared or negative 6x squared. A has always equal to 1, so therefore the quadratic term has always been x squared. But what do you do when you have something like 2x squared? Well, the short version is that it's way simpler to solve an equation that looks like this, x squared, than it is that looks like this. So much simpler, in fact, that we'd rather deal with fractions and completing the square than anything else. That's just as a strategy. So the strategy is to divide all the terms on both sides by a. Dealing with fractions is easier than keeping a not equal to 1. So as a new first step, what you can do is you can divide all the terms on both sides by 2. You might be like, Birdwin, really? You're going to get 3 over 2? And I'm saying yes, it's going to be way easier than dealing with completing the square with a 2x squared term. First step is to add 3/2 to both sides. And you get x squared plus 1x is equal to 3/2. The b value is 1. Half of that is 1/2. So therefore, I know already I'm just going to have x plus 1/2 squared. When you square that, when you square the half of the b value, you get 1/4. So I need to fill in a little space with 1/4. I'm adding 1/4 to both sides, so just to keep things equivalent, 3/2 plus 1/4, well, 3/2 is really 6/4, so we really get 7/4. Taking the square root of both sides, we get x plus 1/2 is equal to plus or minus the square root of 7 over 4. And just simplifying things a little bit inside the radical, that would be the same thing as plus or minus the square root of 7 over 2. Then we can subtract 1/2 from both sides. We get x is equal to negative 1/2 plus or minus the square root of 7 over 2. And then you can even combine those fractions. You get x is equal to one big fraction over 2, the minus 1/2, and then the plus or minus the square root of 7 over 2. And there it is. You can't really simplify the answer more than that, so we're not going to try. You could get decimal equivalents, but just with no calculators, that's what you get. Again, dealing with fractions is way easier than keeping a value not equal to 1. So the very first step is to make the a value equal to 1. You're going to divide both sides by 4. Divide both sides by 4. Divide both sides by 4. Divide all the terms on both sides by 4. We get x squared plus 3/4 x minus 1/4. Gosh, fractions are everywhere. That's okay, we can deal with it. Adding the 1/4 to both sides, we get 1/4 plus 1/4. And then we get x squared plus 3/4 x plus a little space. We get 1/4. And then 3/4 divided by 2 is 3/8. Side work, the b value is 3/4, so therefore multiply that by 1/2, you get 3/8, like I said. And when you square that, you get 9/64. So therefore we need to add 9/64 to both sides. And the part, that's what you add to both sides, and this is what gets filled in when you complete the square. 3/2. 1/4 is the same thing as multiplying both by 16. It's the same thing as 16/64. So 16 plus 9 is 25/64. Look at that. You can take the square root of both sides quite nicely. You get x plus 3/8 is equal to plus or minus 5/8. Subtracting 3/8 from both sides, you get x is equal to negative 3/8 plus or minus the 5/8. And I think I'm even going to take it further because we can. Negative 3 plus 5/8. Negative 3 plus 5 is 2/8, or just 1/4. Or x is going to equal negative 3 minus 5, which is negative 8/8, which is just going to be negative 1. So there are your two answers. X could equal 1/4 or x could equal negative 1. Well, that's about all we got, people. I'd like you to begin assignment 2E1. That means copy the problem list and then do the first problem in your composition book. Take care, and I'll see you in class.